Yeah, so just a quick question. How many of have you seen any of this movie? Have you seen it? Rawa. Right? So all these movie, can anyone say like what is the basic relation? What is the basic similarity which we are to have? So all these movies and beyond these few examples, there is a huge lot of movies which are focusing on the artificial intelligence part. So the basic common link is like through the applications of artificial intelligence, they try to develop something, but they try to create their own movie or platform in that. So you might ask me that, okay, all these are kind of like fictitious stories and like, but yeah, but this is not fictitious. This is the recent trends applications which are based on VR. You know what are these ChatGPT? Yeah. So like ChatGPT, there are a lot of other tools are also available. Like this one, Jasper, Copy AI. So these are all AI-based tools which are creating our life more easier. So you can write some text on the ChatGPT, it gives you some kind of good elaboration on that particular thing. Okay. So this is a small amount of things in which in today's world we are situated. So you want to know about something, you want to know if you are very new in just day one in machine learning, type out in ChatGPT, it will give you the answer about what is AI or machine learning. How it is generated? Have you asked this question? How many of you have used ChatGPT? Can you please raise your hand? A lot of people have not used. It's quite unbelievable. Okay, so, but the question is like how it is generating this kind of answer. And the main focusing point is just go on typing your questions, same question, repeated amount of time, which will be giving you different categories of answers. And for research scholars, the plagiarism score is 0. So you cannot find those kind of line similarity score with any kind of existing score. So basically behind this ChatGPT there is a generative AI model which is working. How it is working? It is fetching all the data from the internet, www server, and then from there it is creating its own sentence. So that's why every time you are getting new and new kind of sentences and paragraphs. Kind of interesting, like the machine which can act as a human, good translator, which is having a very vocabulary, English or any other language. So, like it can create your own solutions at each and every point of time. So that's the power of AI. So with that, so basically, this is the thing that I just want to tell you that with a huge backbone of algorithm and huge amount of data that is present in the internet. These two things are very important from the perspective of machine learning and AI. One is the more and more robust algorithms due to the much more complex mathematical standpoints. And the second thing is a huge pool of data from the internet. So you would be like, I hope everybody is using like Mark smartphones, 2G or 5G like that. Any idea if single person how much amount of data single person can consume in a day? Single gigabyte. Single day, single person can consume to YouTube, Facebook, Instagram, with different set of profiles with around 50 to 20 GB. So this amount of data that is storing on the internet, you don't know, but it is storing because all these things are being stored on some server. Day-2 servers, internet servers, these are different categories of servers available. So with AI and machine learning has become so much powerful that it can be applied to different categories of it. So earlier it was just being limited to robot automation like that, but right now it can be utilized in transportation, in cybersecurity as well, and economic to analyze how the census data will be going up and down in the next 7 days based on the previous day, so that people can share their money on the different stocks. And mobile capability, and the last one is the data science part. So over here, I will try to keep my focus on the healthcare part. Healthcare, again, it's a big domain. It consists of a lot of different disciplines, like starting from medical image analysis to medical signal analysis to bioinformatics. The different types of disciplines are there over in this particular field. So in today's lecture, I will be focusing on my uh, on the lecture on this accelerating the identification of antimicrobial resistance in machine learning. The last lecture, I think, Roshan told you about different process, the heuristic mechanisms which are present in these cells, which are already present, like similarity research, based on which we can find the similar type of antimicrobial resistance based on a given type of database is present. Now, are there any kind of mechanism which can be built by which is searching we don't have to do manually? Because you see, the more days I am talking about will be going in the future, the more amount of data will be generated. In the last lecture, you might have heard about the sequencing machines. So in the last lecture, you have heard about the sequencing machine. Okay, any idea that a human gene sequence, how much of data it can create? A single human. No, it will just go on multiple times, but a single time it could be 250 GB. So just think about, you have a quantum computer, the moderate rate of computer, and you know how you are sitting in front of that. Now I'm supplying you 250 GB one day. Next day it will be 500 GB, third day it will be a terabyte. So do you have the capability to analyze this huge amount of data by doing the systems of similarity research? I believe it will be humongous. It will be terrible for a single person or a even group of 10 persons. So that's why. And on the other hand, you see, we have a very strong domain of mathematics, based on which we can analyze this kind of data. So can we amalgam this two? Then can we create some algorithm or platform by which the algorithm itself will analyze the data and it will give us this kind of output? So that's what the machine learning is doing. So basic learning is what? So in this case, we directly heard about these three terminologies like artificial intelligence, machine learning, and the deep learning part. What are these actually? Are they similar or they are different in some kind of states? So basically, you see artificial intelligence is a huge state which consists of a lot of different categories of algorithms, different types of jobs, like Alexa or Apple Siri. They are the examples of artificial intelligence. Yeah, which can do multiple amount of tasks at a single point of time. But what is machine learning? Machine learning is a small domain within the artificial intelligence sector, which can perform a single task at a time, which is dedicated to perform a single output. And for that, we are developing some algorithm. Now, amalgamation of different categories of machine learning algorithm is creating the AI. So AI can handle multiple amount of tasks, whereas machine learning is dedicated to a single amount, single point, single task. And deep learning again is another sector in which the people mostly in this space they are working. So deep learning is highest amount of mathematical knowledge that we can implement within the machine learning sector. Okay. So much more complex mathematics we are implementing to keep the same output but with a better accuracy, reduce the amount of time and a better judgment. Okay. Now let me tell you about something that the evolution of this part. Because I personally very much respect this particular slide because this will tell us that how gradually we are evolving in this particular domain, in the domain of machine learning. So it has been started, means I don't know how many of you have read the data of ancient literatures. But long time back, there was some kind of, we can find there a lot of mentions about intelligence in our ancient literatures, like Buddhi, we can find Gautam Buddha, and Veda. So, in those kind of philosophical directions, we can find a lot of inputs or words or learnings which represents the intelligence or the learning part. Okay. Now let's come back to the 1930s, where the Second World War is going on. How many of you have seen the movie The Imitation Game? You must, you must watch. It's a very good movie. It was based on the Second World War and based on the life of Professor Alan Turing, who built the machine. He was named as the Turing machine. That was considered as the first implementation of AI. So what was its purpose? The machine can track the messages came from the journal and it can decode it. So that point of time, every day the passage is getting changed. The encryption was very difficult. So Professor Alan Turing and his team worked on that particular project during the Second World War time, and they created this particular machine which can automatically decode their messages. Okay, so it's a big invention, and that was considered as the first AI output. Before that, we don't have any kind of historical evidence, but that in the 1930s when Professor Alan Turing or 1945 when it was not published. So that was the first outcome of the AI agriculture. Then later in the 1950s, like we came across different kinds of computer games. The first one was the Samuel's checker player in Selfie's Pandemonium. So these are the two first computer games we first played. Human can play with the computer. Again, another creation of creation of the artificial intelligence algorithms. Then later in the 1960s, which came across the development of the artificial neural network. So that this particular domain, artificial neural network, is entirely based on the concept of how human brains are working, based on the synaptic reactions and the action neurons that are present in the human brain, how they memorize and learn over the time. Okay. Then in the 80s, we came across again another thing in the mathematical concepts, and gradually we goes inside the rule-based programming and learning algorithms. Then in the 90s, we come across reinforcement learning, taking step by step, this gradually implementing the mathematical concepts and different analogies are coming out, and people are developing a lot of complex and much more complex algorithms. And right now, we are in the age where almost in every sectors, in industrial sectors, you can find the applications of AI, either for doing any kind of judgment or doing some sort of analysis. Okay. Now over here, I just want to mention that there is a difference between memorization and learning. Any idea of what is the difference? Please say whatever it is comes to your mind. Any idea of what is the difference between the memorizing and the learning from a human's perspective?
Learning is a process where the whole concept is explained, out of which a very small percentage is can be not but memorize the whole learning. Part of it is being down. The short memory will be done.
So memorizing means like we are keeping inside the memory, but not utilizing in the simple sentence. But learning means gradually we are experiencing the domain and we are learning the hidden things. Like all of you know about a plus b whole square equals to a square plus 2ab plus b square, right? You agree with me or not?
Yes.
Yes, definitely. So now just go back to your class 5, 6, or 7 like that. So if I just take a equals to 20 and b equals to a, you can easily say like what would be the answer. You mean now in the question, you might get a equals to 10 and b equals to 20. So what is the difference between that? I am entirely changing the input, but the learning that is already been created into your mind, using that you can now create another lesson. Okay. So that is the difference between the learning and the memorizing. So learning means you understand the steps or the process by which you can come to the final outcome. Okay, so that's what we are doing throughout our lifetime. Even till date, I am also learning because bioinformatics is quite a new subject to me. Again, I told you I'm not into biology, but I know how to implement the data, how to take it as a data, and how to do the analysis. Now, okay, talking about this machine learning, I want to quote one of my favorite Professor Tom Michel, who has explained the machine learning in the by far the most interesting way. So any kind of problem in nature or in this world, if you can um, parameterize or if you can define it using three parameters. One is the experience T, another is the task T, and third one is the performance P. Then that particular set of problem you can model it using it. So only these three things. Think about any situation in nature, starting from earthquakes to like your normal study. So if you can like find out these three parameters for that particular problem, you can easily code machine learning for that to solve something for that. Okay. And it has three basic components for each kind of machine learning algorithms that we are dealing with this today's day, today's world. The first one is the algorithm part, in which we have a lot of different types of algorithms present. Like no one can say like how many, what is the exact number of machine learning algorithms are present in this. Can be like more than 10,000 or 20,000 like that. So a huge number of application algorithms are present in this particular domain. We apply a few specific algorithms to solve our purpose, and each of the algorithm can be represented or can be applied in different coding sets. Okay. So few algorithms, for example, can be utilized, can give very good result for images. Like if you're when you're doing face recognition or visual inspection or creating some avatar. So these are the so for when you're dealing with different types of images. So then few set of algorithms can give you very good result. While you are doing working with sequence data like genome sequencing data or protein sequence data, so there are different categories of algorithms present which can give you a very good result. The second part is the optimization. For each algorithm, like I say, the entire machine learning domain is mostly oriented on the strong mathematics. So every time you have some kind of parameters that you have to tune. For example, if I am talking about a simple straight line, y equals to mx plus c. So here we can find two parameters. One is the a and another one is the c. So for a particular problem, we have to find out what are the values of this a. Because machine understands only the numerical value. They do not understand any A, B, A, C, C, G like that. So for that, we have set of optimization algorithms, okay, which can be implemented to tune these parameters for which we can get a very strong or good results. And the third one is the evaluation criteria. So basically, there are different types of criteria like accuracy, sensitivity, specificity, then true positive rate, then R1 score, precision. So these are the different types of measurement metrics by which we can say that how good a particular algorithm is. Okay. Now let us focus on how a particular machine will learn. See, as the simplicity is ended up in the mind where you have almost zero knowledge of this, so I'm just going to give you a very short glimpse that how we generally program, starting the program. Then in the next half of the session, I will show you how a machine learning program can be developed from the Python environment. Okay. So now what here you see there are a lot of different block diagrams available. So this is the problem environment. Like if you are working with genome sequence data, so that is our problem environment. If you are working with surveillance, then a set of images is a problem environment. If you are working with the financial sector, then the past data of different stocks is the problem environment. So like that way, different times the problem environment is going to change. Okay. Now, what we generally do, we first try to acquire some important attributes from the problem environment. What are these attributes actually? So, let me give you an example. Think about the COVID era, the beginning of the COVID era. So, when you go to the doctor, suppose you have some kind of cough, cold problem, and you visit the doctor. So, what are the first questions the doctor will ask the patient? What are the yeah. Are you having fever? Or are you having cold and cough problems? You have problem in taking the breathing. So what are these? For a doctor, these are the symptoms. But for a patient, these are the features or attributes. Okay. So for different problem perspective, we want to collect this kind of attributes which can specify or which can signify better the particular environment. So once that attribute collection is done, in the next phase, I will start my program. Okay. So now, for the programming can be done in two stages. First one is the training phase, the second one is the testing phase. Okay. What are these two phases? Again, let me give you another example that you have a 4 to 5 semester program, right? So in these 4 to 5 semester programs, you have to go through a lot of classes and everything, and then at the end of the semester, you have to take the examination. So just think about this is a training and testing phase. So in the training time, a lot of information will be given to you so that you will be enriched with that particular subject. So that is the training phase in which you are getting trained on that particular subject or that particular field. Okay. Similar way, for the machines also, we have the training phase. So the majority amount of the data, like for example, whatever the data we have gathered from this problem environment, so majority amount of it, like 70 to 80% of that particular data, will be used for the training of that particular machine or that particular algorithm. Now, once the model will be trained, like once your theoretical sessions will be over, then it comes to the examination phase, right? So for that, So we name it as a tasting phase. For machines, we name it as a tasting phase in which we will try to utilize the rest 20% of the data and we try to see how the machine is performing, how much accuracy it is giving me, how much precision or recall value it is showing me. Depending on that, I can judge that how good that particular algorithm is. Okay. So that was the training and testing phase of the machines of that particular machine learning algorithm. Now it may happen that at the first iteration or at the first time we are getting a very poor accuracy for the test. Then again we have to review that. Like if you want to have got something, then again they have to see for the re-examination. So that means the retuning the entire phase again. We have to do that. So uh, that is a thing. Similarly, for the machines also, if you are getting a very poor result at the testing phase, then in fact we have to retrain the entire algorithm. We have to do step by step like whether I have done any kind of mistakes in the coding or what are the mathematical concepts that I have utilized for the coding, whether is there any kind of like problem is there or not. So all these parameters we have to judge and again we have to retrain the algorithm. Until nowadays I am getting a very good testing accuracy. And once the model is showing me a very good accuracy for like 85% or more than 90% like that, then I can tell that, okay, my algorithm is ready. Now it can be deployed for the practical usage, like for the market. So whatever the mobile phone applications or AI-based applications or your Alexa, whatever it is, you are showing. So all they have gone through this different phases. And whatever you are getting as an end consumer, so those are the deployment. Okay. So you are getting the end product. Now, if I am talking about a generalized process, keeping in the mind that I am working on this biological environment, so just I am trying to form it in a block diagrammatic way. So the first I will collect the data or information from the environment. Then I will do the pre-processing. Like man told you about their data might be have a lot of noises or redundant data or there might be a lot of same kind of. So on these things we have to pre-process. So for pre-processing we have different types of algorithms are there. Like noise removal, redundant data reduction, missing value change. So these are the different types of pre-processing that can be done. Again, it depends on what environment I'm working. Based on that, the pre-processing algorithms can change. Suppose I'm working on the face recognition domain. So based on that, the pre-processing algorithms will change. We have to enhance the contrast of the image or modify the tone of that particular face like that way. For those are the pre-processing steps for the image related application. When we talk about sequence type of data, then we just go over redundancy removal, noise removal, all this sort of thing. So once this part is done, the next part will be feature extraction or feature creation. So from the environment, I have to create a good amount of feature which can represent the entire thing, entire particular problem. So that way we have to create different kinds of features. So a lot of features are there like shape, size, active feature for genetic sequence data. There are different types of features are also present. I will take once I will talk about a specific example. And the last phase is development of the machine learning algorithm. So whatever the feature that I have extracted from the algorithm, from the environment, that will be now given as an input to the machine learning algorithm, and the algorithm will try to learn and experience about the environment, and based on that, it will give me the final decision. Okay. So this is the generalized block diagram of a machine learning based application. Now let me give you an example. So here I want to give a small example just to like, make you will see about that particular problem for the previous block. So suppose I'm working on a environment where I have been given different kinds of MRI, plain MRI, and a set of MRI images are present which represents the normal patient, a set of images which is representing the presence of a plain tumor. Okay. So I have to develop the algorithm by which the model, the algorithm can say by its own, like which patient is suffering from that. Like whether it's a normal patient or is a brain tumor patient. Okay. So that is the thing that we have to do. So like that way, this kind of MRI images has been supplied to me. And I'm going to create an algorithm for that. Now based on that, first what I will do, I will create different types of features. I will do some, first I will do some pre-processing definitely. Once the pre-processing is done, then I will create different types of features. Over here, the contrast could be one feature, the shape of the tumor could be another feature, the tissue composition could be another feature, how the tissue is reacting with the exposure, that is another feature. These are the different types of features that I can create from this type of images or from this camera. Okay. So like that way, you see, this is the feature matrix that I am doing, where each column x1, x2, like x2. So these are representing these different features. So each column in this matrix is representing different features, and each row in this matrix is representing different samples. Okay. So this in machine learning terminology is said as the feature matrix, and in this feature matrix, each column is representing the features, and each row is representing the different samples. And along with that, you see, I have a class information as well. Class information means, as a prior knowledge, I know which image, whether that particular image is a normal image or a tumor. Okay. That information I already have. So that is the class information that I. This is not a feature. This is the prior information about the class. Feature are these. Okay. Now what I will do? First, over here you see I have 3,000 number of images. For example, it could be 10,000, it could be 3 lakhs as well. So the total number of samples is 3,000. What would be the next task? Anybody? Anyone? I have computed the feature. I have the feature in my hand. Now I want to start the machine learning program. In the feature computation, you see this is not a machine learning program. This is just capturing or acquiring features from the environment. Now I will start my machine learning algorithm. So what will be my fast? Yeah, definitely. But for that, I have to divide the data into two bins or two categories. One is for the training phase, another is for the testing phase. That is very much important. You cannot avoid it. Okay. So, like I said, majority amount of the data will be kept for the training purpose, and a very small amount of data will be kept for the testing purpose. Why? You can ask me why. Anyone is having this question, why? Because majority time amount of the time will be spent for you to train in the semester. So lot of time will be taken for the training. That's why huge amount of knowledge or data we have to give to the machine. Machine it's like a baby. You have to give a lot of effort to make it learn. Then over here I am using say giving 2,000 amount of samples for the training purpose, and the rest 1,000 amount of samples for the testing purpose. Then the next is we have to utilizing these training samples, we have to start the training phase. Like I have to create my machine learning algorithm. It could be any algorithm. So once my algorithm will be trained, how I can find out that my algorithm is trained? Based on the different metrics like accuracy, sensitivity, if all these values are giving me a very good score, then I can say, okay, my algorithm is failing right now, and it can be tested. So the next, this 1000 amount of samples will be utilized for the testing part. And if my testing accuracy is not good, then again the retraining has to be done. But until unless I am getting a very good accuracy over here at the testing phase, till that point of time I have to retrain the model, or maybe I have to switch the model. I have to utilize another type of model. Okay. So this is a generalized framework how a machine learning algorithms is developed. And now with that knowledge, let us dive into this particular section that how machine learning can be fit to identify the antimicrobial resistance. Okay. Be frank, like I want to be frank. If you are asking questions on the bioinformatics that I will be available, possible to give you the answer. And that's a very better answer. But I just think this particular sequence data as a matrix. To me, this sequence data is just a matrix. And after that, how to process, that is my task. Okay. Now, why this is important? Okay, let me tell you that antimicrobial resistance is getting very much significance in this particular domain because here and there we can take a lot of antibiotics even if without the concentration of the proper target. Sir, I think you will. So it is creating some sort of resistance inside our body. The bacteria are getting resistance to that different kinds of antibiotics. So that's why here, to some machine learning algorithm, and you see, for to do this sort of analysis, we already have a lot of amount of data. So that's why we are trying to develop some kind of algorithm by which the algorithm can itself see that whether a particular sequence is having the antimicrobial resistance property or not. And if it is, then what kind of antibiotic it will be resistant to. And along with that, the most important part is what you just asked me. Like about the similarity-based scores and the features. Here we also try to find out the significant features, the short patterns of ATCG, which will be responsible to identify that which active sequence will be resistant to which antibiotic. Okay. So, yeah. The focus of our study was on the escape. I know, like, you will be better to know why I am focusing my study on the escape because that is mostly available on the data set part as well as in the nature. Okay. Now over here, this is the process that we are going to implement. So the first will be data acquisition. Data acquisition here we utilize in NCPI web resources for downloading the data sets. Then we will do the pre-process. Then we will do the pre-processing part of the data because I told you that whatever data we get, even if it is generated from lab or coming from whatever the domain, every time it will have some kind of noise. There will be a lot of redundant data, but the same sequence is repeated again and again. That is not required for me. It is unnecessary bargaining in my algorithm. So we have to identify and discard the same sequences at the same time. So that is the pre-processing stage. Okay. And a lot of other things also will be done, like finding out the code engineers and all these things. That will also be in the pre-processing part. The next part that is coming the encoding. Now from here, the machine learning is actually started. Why? Because if you keep in mind that I already told you, machine does not understand any kind of alphabets or any word or anything. It just understands the numeric numbers. 1, 2, 3, 4, like integers. It will already integers or floating point numbers. It only understand that. So ATCG we have to convert into the number form. So that process is known as the encoding. Like if you want to model what will be the weather for the upcoming 7 days based on the data for the past 1 month, Here you will get sunny or windy or rainy, this kind of data available. But machines does not know about the sunny, rainy or windy. They only understand some encoding patterns. So at the beginning of the algorithm, and we have to convert all these alphabets or all these non-numeric data into the numerical number. That particular process is known as the encoding. There are different algorithms are present, like one-hot encoding, target encoding, schema encoding, FCGR. So these are the different types of encoding that we could use for this particular approach. Sometimes we can also do manual encoding as well. Okay. Manual encoding means like you see A, C, D, only 4 characters are getting represented every point of time. Like A, C, D, E, nothing out of that. Only ABCD4 letters are there. So we can manually encode. We can keep A equals to 1, B equals to 2, C equals to 3, E equals to 4, like that way also. So that is known as the manual encoding. Means before assigning the problem, we just getting the sequence, we just manually label all these letters as a numeric. So now I have the sequence where A will be represented as 1, B will be represented as 2, C will be represented as 3, and D will be represented as 4. So that is a kind of manual encoding. Instead of manual encoding, we can utilize some sort of automatic process. One of them is one-hot encoding. It's very much used for the sequence type of data. Another is schema encoding. So some schema patterns will be utilized to find out from the sequence. Then FCGR encoding that could be also utilized. So these are the different kinds of encoding that we can utilize. In today's this particular example, I will show you that how schema encoding can be developed. And the next is implementation of the machine learning algorithm. So once my encoding process is done, then the next process will be to implement the machine learning algorithm to get the proper decision. What is my target over here? You see, my target is to, given the sequence, the algorithm can see that what particular antibiotic is resistant to that particular, that sequence is resistant to what particular antibiotics, and what are the important features that could map any sequence similar to that would be resistant to the same antibiotic. So these are my targets, these are my decisions. Okay. So machines will generate this particular decision. Now let us try with the data acquisition part. Like I told you, we are downloaded it. So
yeah, I can. All of you have it.
So yeah, in that tutorial we get again step by step all the details. So what I have done actually, so I told you that these are the 2 stages. So data acquisition and pre-processing I am not going to show you today because this is again a laborious process and task. And there, let me tell you that what I am showing you, there is a 2 months of work. So it's very hard to explain it 2 hours. So this data acquisition and pre-processing, just follow whatever details on the tutorial portion. You can easily do the job. So what I will start from the encoding and do the machine learning. That is the focus of this particular thing. Now, in the data acquisition, like I told you, we are keeping our focus on the Sept pathogens, and we just take the figures like this. Those were homogeneous, then we focus on the complete details, then we particularly focus on the coding regions as well. Why is the coding regions? I think it was clear on the previous lecture. Then what we saw is that I think we gave the slides. Slides will be shared with you. So you don't have to take it forward. This is so this is the count of total number of sequence based on the escape. So Enterobacter, Cephalococcus, these various pathogens, these are the total number of sequences that we got from the NCBI database. And we also find out the total number of strains for it. So these are this is the plot for this particular thing. And after doing that, the pre-processing stage, first we do the CDD. CDD is doing what? It is just giving you the first form of cluster. So there are a lot of, if you consider a single pathogen like Acinetobacter, so even in that you have a lot of different types of sequences present. Now at the beginning you need to have a rough idea that what are the different sequences are forming a single class. Okay. Based on which you can start your machine learning algorithm. So that is the prior knowledge. I told you the class information that you need. So that class information you will get from the CD. So it will gives us the different cluster. Similarly, similar like sequences will be clustered in a sequence. So like that way, once we done, we keep the parameters and similarity matching as 90%. So the sequences which are matching in the 90% similar, they will be clustered in a single cluster. And we keep the coverage as 80%. Okay. So that way when we implement the CD, so this is a web-based platform. If you just write it, simply write it on the Google, you will get all the web server and everything. So we will get, we are getting display number of clusters for each and every package. Okay. So for Enterococcus, we are getting 9,693 number of clusters, and here you see for HCl, we are getting 56,031 number of clusters. That's a very much highly valuable. After that, we are doing the core finding. So here we try to do the finding out the core regions of the different sequences, and what we got is very number of codes for these different pathogens. We are getting this many number of codes. Here I am showing you pathogen specific result because what we have developed the algorithm of finding the pathogen specific. Okay, in this core finding, you need to go to specific. Yeah, for KFC or this specific. Then for Acinetobacter not. So because whatever the algorithm we have developed that is specific for each and every pathogen. The algorithm itself is the same one, but I told you that every time we have to do the training phase because the parameter tuning has to be done. So that's why for pathogen specific parameters we will get over. Now we do the RGI, resistance in identification. Like through this particular approach, we will get like which cluster is resistant to what particular antibiotic. So there the entire database is present, RGI. So if you just follow the steps that has been written on the tutorial, you can easily do this particular find. So what we get that for KCL almost there is no clusters which are represented to any particular antibiotic. But for Acinetobacter, we got 4 clusters which are resistant to some different antibiotics. And this particular RGI is actually providing us some ARO number. This ARO number is significant from the point that it is showing that this particular cluster is resistant to each particular antibiotic. That particular ARO number is signifying that one. Okay. Now moving ahead, so we after that we are doing the SNP and the alignment because I told you over here we are doing the KMR encoding part. So for KMR encoding we have to align the sequences and do the SNP. Now after that we are doing the KMR encoding. So what is KMR like? Here we have used the 4 mark. You see the patterns over here. So we have 4 layers or 4 nucleotides A, B, C, G, and when you see the 4 mark, how many numbers we can utilize different combinations like A, C, B, like that. So it's a kind of 4 combinations that we can create when you are utilizing G equals to 4. We can keep k equals to 6 as well, k equals to 8 as well, based on the different number of patterns can be. So this is the schema encoding that we are utilizing over here, so that we can find out how many number of the storage repetitions are present in that particular sequence, or how many number of triple AC this particular representation is present in that sequence. Okay. So that way will be just count. Now what you see, all the values are being given. Okay. Before this particular point, we have all the kind of nucleotides or alphabets present. Now over here, everything we have represented in the numerical form. Now it is ready to implement the machine learning algorithm. So in the machine learning algorithm, so what we are utilizing the support vector machine. It's a very powerful algorithm based on a very strong mathematical concept that has been created, and uh, it can be applied to any kind of data also at the same time. So what we have at this point, we have the K-bar matrix, you see, that we have created. Now we try to think about pathogen specific analysis. Okay. If we can find out, if we can create a single algorithm which is better working on a single pathogen, then it can be applied for 4 other pathogens as well, or 5 other pathogens as well. So that's why we have a K-bar matrix. For example, this is the K-bar for the acyclovir. And along with that, we have the same ARO numbers. For each sequence, we have the ARO numbers which we receive from the RGR. And I told you, remember, this ARO number is actually pointing that this particular sequence is resistant to each of antibiotics or antibiotics. Okay. So that is the number that is signifying. So these two things that I have. So this is the training data, and that is the annotated labels. Labels to the class. Which particular sequence is resistant to which particular antibiotic. Now, using these two information, I am creating a machine learning algorithm. Over here, I am creating SVM, support vector machine, in which once the algorithm will be trained, then when a new sequence will be given, it will give us a particular ARO output. That means this particular sequence to resistance to which particular group of antibiotics or antibiotics. Okay. So that is the what that this particular algorithm can be done. And over here we are not doing any kind of similarity investigation like you asked the previous. Over here the algorithm is trying to find out the pattern. Like I told you, similarity based measure is just the memorizing. There is no learning in that. So machine learning is actually trying to find out the hidden patterns based on which this particular set of sequences can be assigned to a set of AROs. It is trying to find out those hidden patterns. And what we find out, I will show you the patterns as well, and they are significant scores. So over here you see, among these patterns that we have computed, K-bar patterns, any one of the patterns could be important, or a group of patterns could be important that for which that particular sequence could be tagged to that particular year. That we are identifying. Over here we are utilizing K equals to 4, that's why you are seeing that over only 4 characters combinations are present. If you are utilizing K equals to 6, then it will be 6 characters combination, or K equals to 8 or 10, that way you can utilize for increasing your data. Okay. So now how this particular problem is solved, and I think I should explain because as a strong mathematical thing. So if you are interested, then you can possibly contact me that I will go to you. So these are the different mathematics based on which that algorithm will try to learn. Can you just yeah, that's the fine. So that makes sense. Okay. So now let's start with the tutorial. Then we will get to know that how the algorithm will be performed. So just keep it in mind that at the input we have the K-bar matrix or K-bar data. For k equals to 4, I have supplied you the data. So whatever the input files that you have received yesterday, right? So those are representing the clusters for the Acinetobacter. Over here for the time, like I'm focusing only on the Acinetobacter. The same algorithm, whatever has been given on the tutorial, you can implement it for the other pathogens as well. You will get the same results. Okay. Now, for the Acinetobacter, like I told you, we got 4 clusters, 4 codes. Okay. Now, those 4 clusters are representing 4 different years. So that's why it happened at my point. So now, using this data, I will try to build the SVM algorithm in Python environment, by which the algorithm itself will try to find out the given unknown sequence, what will be its particular year. Okay. So that is my target, and also at the same time, the second target is it will try to find out the k-naught patterns which are responsible to tag a unknown sequence to that particular layer. That is, those are the features, important features that could be given supplied by the machine learning algorithm. So in your tutorial, the first phase is considered about the data processing. Just open your tutorial right now. Or yeah, so the first part, if you can open your tutorial, then you see like this is just how to download the data and do the pre-processing part. So I'm leaving you for you can do it at your home or at your other times as well. So I have already supplied you see these files, cluster 387.pasta, cluster 583.pasta, cluster 2266.pasta, and cluster 17417. So these 4 clusters, they are representing the 4 clusters of the Acinetobacter. Okay, okay, the 4 groups. Uh, two, and this Acinetobacter, this is the ARO information that we are getting as an output of the resistance identifier. That is also a web-based tool which you can easily do as a preprocessing. So what we have the 4 clusters, and also along with that, we have the ARO information for each and every sequence. Over here, I am representing cluster 57. This is the cluster for a thing completely different bacteria. It's a E. coli. Why I am keeping that? Because for the machine learning algorithm as a programmer, it is our responsibility that if something is not matching, then we have to create it as another class, which is undefined or unclassified. So that we have to also provide. So suppose like we are training with only these 4 clusters and something new data you are giving which are outside of these 4 different clusters, then the algorithm cannot give you the output if you are not keeping a separate class as an unclassified. So it will just hang. It will not perform. You will not see any kind of output. So that is the reason that we are utilizing a completely different bacteria cluster to train the model so that any kind of unknown sequence when it will appear to the algorithm can say that okay, that is not belongs to this particular category, it is unclassified. So unclassified means it is not belonging to that particular pathogen. Okay, so that's why I'm utilizing this cluster 57. Remember, so only 4 clusters are present over here. When I am considering only the Acinetobacter part, only these 4 cluster files, they belongs to the Acinetobacter pathogen. This RGI Acinetobacter is representing the ARO number that is the class level, and the final cluster 57 is the cluster for the Ebola, a random cluster that we have created from the Ebola experience, and we just name it as the unclassified. So we do not need any kind of ARO for that because we are keeping it as an unclassified. That means if you are just giving any kind of random arbitrary input to the algorithm and it does not belong to the that particular group of pathogens, then the algorithm can tell you that okay, it is a unclassified. Okay, so that is the reason that we every time we have to keep it. Means if you think very logically, it is also true that if you know a person, then you can name that person. Okay, that is the name of the person is this. But from a human perspective, if you don't know a person, then you can also say that I don't know. So I don't know. It's also a class information. So that's the reason that we have to keep this unclassified as a class. Okay. Now, these 4 files. So, for the starting of your program, I just ask you to go to the Google Chrome. I hope every one of you have the Gmail, right? Gmail you have? Yes or no something? Yes. So, just log into your Gmail and use Google Chrome, not Microsoft, not any other way around. Because over here for the Python programming we will use Google Colab. Okay, you can download. There are a lot of different programming environment present which you can download on your system and you can program. But my point is, if Google is giving me free some computational stuff, then why should I bother my own time? So that's the thing. So Google is delivering us the free web resources. Like you will get some amount of RAM, memory, everything will be named onto your email. So just log into your Gmail. Please, okay, can I proceed further? Okay. So now go to another tab, new tab, and type out like your collab. Just simply type out collab. Go to another tab. Type collab and keep it. It will ask you about the permission of your Gmail drive. So just keep the permission. Okay. Okay. So now just go to your Gmail, and over here just go to your the drive. Okay. So here you will see one folder has been created as the collab notebooks. One folder will be created. Once you have created, give the permission for the using the collab using your Gmail drive. So one folder will be created named as collab notebooks. Is it so? Have you found out which collab notebook? No?
No, at least
Yeah. You are perfect.
some of you are perfect.
Collab notebook, or you can search it. You can search it in this over here. Collab notebooks.
Just go to your drive. Google Drive.
So you see, like your Google Chrome have is signed in. You are signed in the Google Chrome, not the Gmail, using some Google Mail, right? So Google Colab will be created on that.
My email is also open, so you can prove that also.
Yeah, that's what I was trying to show you. So I'm showing you another way. Okay, so forget about just look at the screen right now. So just create a new tab, write Colab, and enter. So go to Google Colab, start with new notebook. Okay, start with a new notebook. So right now this is the coding area that you will get. This kind of coding area. So you can name your program over here, which is named as untitled 0 right now. So you can name it a 0, you can name it your program, and the file is in a general format. It will be stored as the IPyInp, which is utilizing the Python backbone. Okay. Now what I am telling you over here, you have to connect. So you, when you just click on the connecting, it will show you this kind of messages. Visualizing, then yeah, right now it is connected. So over here you see you are getting some RAM, say 12.7 GB of RAM and 107 GB of hard disk to use. So this is Google which is providing you. This is not within your machine. So if you have the subscription for the Google Colab as a professional one or professional plus one, this kind of facilities will be further more. Okay, so this is the computational power that the Google is providing you for doing your program. They are not utilizing, so whatever the program you will write it over here, they are not utilizing your computer memory, rather it will use the memory that has been provided from the Google side. Okay. And over here on the left hand side, you see there is a folder icon. So if you just click it, you will get all the folders that are present or that will be created during your programming. So everything you will can see. Now, as I have created already the program for you, uh, easy. So I'm just opening it over here. Okay. Fine. So on your screen you are having the untitled, but over here I have already created the program. which I have given the same thing on the tutorial now. So now, in this first part, first what we have to do, over here you see, I am getting some RAM of this. By default, Google is allocating me something 30 GB of RAM and some 100 GB of space for doing my computational stuff. If I am just going for Colab Pro professional version or professional plus version, then the number of more memories will be better. Now, on this side, this panel, we will get the list of folders that the Google Colab, the programming environment is accessing. Okay. So, as we are in the Google Drive folder, so whatever the Google Drive folder you have, that will be listed over here. So, the first task I have to mount, because whatever the data that I will be giving as the input, that has to be uploaded on the Google Drive folder. Okay. So the data that you have received yesterday, first you do one thing, you just upload it. Like over here, you see I have created one NBU folder. So under NBU, I have created one Actinobacter. Then double clicking on that, I have uploaded the files. So these files I have already shared with you yesterday. So just upload it. So create one folder named as NBU. Inside it, just create another folder that has Actinobacter. While writing the names, please be on side, because if you are doing any kind of mistake, the program will cannot access the path. Okay? So that's why just try to name the path properly. So NBU, then Actinobacter, then under which I have uploaded all the files. Have you done uploading all these files? Yes? Yeah. Yeah. Okay. So just upload all the files that you just download this files, unzip it, and upload, drag and drop to the folder. Similarly, yesterday you have received those data like right? uploading the file just go to your Google Drive, create one folder named NVU. Go inside that, create another folder named Acinetobacter. Go inside that, double clicking it, and upload all the files that I shared yesterday. What we have. Just drag and drop. Simple drag and drop. Done. Which way? Done. You want to change the because otherwise you have to take some time. Done. So can I move ahead? Okay. So now again under this Acinetobacter folder, create another folder as 4 mark. Just keep it. I will tell you why I am creating this one, while I will show you the program. So just create another folder under the Acinetobacter folder. Create another folder named as 4 mark, like it is shown in this particular thing. Yeah. Is it done? Okay. Now let us go to the programming environment. So now that is the data uploading part has been done. So I have I have uploaded all the required files on the Google Drive folder. Now as Google is providing this computational platform, so whatever the data I have to access, like something I have to take as the input or something I have to give as the output, so everything will be saved on your Google Drive. So that's why I have to do the data uploading part prior to the program. Now once the data uploading part is done, the next part I have to mount my drive. That means I have to, so this is a programming environment where I have to mount by writing these 2 lines of code. Now go to the tutorial part. So there you will get 2 lines of code for mounting your Google Drive. Just copy and paste on the first cell and run it. So under each cell you will get a nice play button. So just click on that button. It will go circling like this way, and it will show you once it will be stopped. Okay. So like this, you see the first task I am doing, I am just clicking on here. So it is asking me some permission that whether I would like to mount my drive from or not. So connect to Google Drive. So I am utilizing my email, where email ID under which I have uploaded the folders, and I am giving the permissions. Okay. So it is asking me the permission, then I am just allowing. Click on the allow. So here you will see. So this is done. Now the running is done. So here you will see a small right tick and under which 1 minute is written. That is the execution time. Okay. And at the same time, if you just refresh it, you will get this drive location. Drive folder. So all your Google Drive now is uploaded on the Colab platform. Yeah. Yeah. No. Let's go to the top PDF. You have to copy from system file. So within this rectangular thing, all these, whatever the things are present, that are the codes. Yeah. Now, this is the information and this. Yeah, is it done? The first step, mounting the Google Drive. Is it done? Okay. So now, if you just go to the next step of the tutorial, after mounting of the Google Drive, now over here you can see that if you just click on this drive and my drive, then you will get this NView folder. Okay, under which you will get the Acinetobacter. All the files are shown. Right? So the next process is what? Next, we will do the Kmart computation. So I have the 4 clusters, like I told you. What I have to do? I have to do the Kmart computation. So just go to the tutorial PDF. So there you will get this code. There will get a small instruction to install the BioPython. So BioPython is a library of the Python which consists of different types of syntaxes which could be utilizable during our program. Syntaxes are what? Yeah, syntaxes are what? It is like a huge amount of code can be represented in a single form. So that kind of syntaxes is used because over here we are dealing with master files. So that's why to read the master files in the Python environment, we use the BioPython tool or the BioPython library or the package. Okay. So first, again you just copy and paste. Just click on the above you see over here there is written class code. Just click on that. You will get another tab, another blank tab. Now copy that particular install BioPython thing under this particular blank tab and run it. Okay, is it done? So now the BioPython has been installed in your Python environment. Now you can easily call the pasta files in your Python environment. So to do the KMR computation, just go to the tutorial file, and in the first step you will see that there is written KMR computation. So you just copy the entire code that is present within the rectangular box. Copy the entire code that is present in the rectangular box and paste it over there in this particular environment. So I am talking about this particular area. You see on the screen. So this particular area I am talking about. So copy this entire code, this entire thing on a single cell. So like over here you see there is it is copied. Okay. And at the bottom you see the path is mentioned. Just look at the screen over here, please. You see the path is mentioned. So this path is actually the location where you have dumped all your input files. Okay. And this is the output path, the format, that file that you have folder you have created. So that is the output path. Are you done? What I am telling that this video here. So under this schema encoding we get a data version. Just copy it and create a new cell on this by clicking on this code, class code. You just click on this class code again, a blank cell will be created. So paste it. Just Control C and Control V. Okay. So that way, and you just run it. So you will see the KMR file has been created for cluster 387. So this entire bunch of code is accessing the cluster 387 from the Google Drive. It is doing the KMR computation based on the 8 works code, and again it is dumping the output in this folder 4x4 mark. With under the folder again you will get cluster 387 underscore 4 mark dot CSV, which is actually holding the KMR matrix. Okay. Is it clear? Now, how many clusters you have? For Acinetobacter, you have 4 clusters, right? So you have to read it. This 387. The next cluster name is 583. Then the next cluster is 2266. Then next cluster is 17417. So same code you have to change the name and again rerun. So over here you see in the path name which is mentioned cluster 387. So once you run, you just check on the Google Drive folder the KMR matrix corresponding to cluster 387 has been created. Now the same thing you have to do it for the other three clusters. Okay. All the fixes I made it. Is it done? Have you done for a single cluster? Okay. For the time being, you just look at over here on the screen. Excuse me, if you are, can you see on the screen right now? Please. You can try out later because I'm running out of the time, so that's why I just want to show you what is happening. So everything is mentioned on the tutorial part. If you just follow the steps, but right now I am showing you how to do that. Okay. Please keep your focus on the screen right now. So first, what I will do, I have. So let me just go back to the acidomacter file. So I have these four clusters which belongs to the acinetobacter. Okay. And also I have this RGI information, and this cluster 57 is belongs to the E. coli. Again I am telling you that is not belong to acinetobacter. So now I am running the KMR computation for the first cluster, which is cluster 387. So I have copied and pasted. So you please see all the indent over here. There is a gap, there is a gap. All these gaps are meaningful for the coding purpose. Okay. So I'm just running it. The computation is done. So if I go to my Google Drive and the 4-bar part, let me just refresh it. Here you will see the cluster 387 4-bar file has already been created. Okay. Now this is the KMR matrix for the one cluster only. Similar thing we have to do for three other clusters. So what I will do, I will just change manually the names over here. 387. So the next cluster name is 583. Both input and output I have to change. Then again I am rerunning it. So the running is done. Again, if I just refresh this Google Drive folder, Here you see 2 k-bar computation is done. Okay. Now similarly I will do for the 2266. And for the final cluster 17417 17417. So if I just refresh it, yeah, here you see all the 4 k-bar matrices computation is done. Now what I have to do? The k-bar computation is not completed because we have another cluster for E. coli. So we have to do the k-bar computation for the E. coli also. So cluster 57, and I am changing the output path, just the parent folder. So under this 4-bar folder, I am just keeping only the k-bar matrices for the Acinetobacter files. So now I am running it. Then go to the Acinetobacter file. Here, let me just refresh. Here you see raster 57 4-bar CSV file is present. So now what I have done, I have computed all the k-bar files in this point. Now the next part is I have to call all these k-bar files along with the ARO numbers to create the SVM, okay, to create a machine learning model. So here you see I have called all the input files that I have just created. Okay. So the first RGI result, this is actually notifying me the ARO numbers. This CSV path is actually notifying what will be the path where the output file will be saved. This is the E. coli CSV file, that means for the unclassified data, and that is the output path. Okay. So now here I am merging all the files, k-bar files that I have created for the Acinetobacter. So let me just run. So here all the k-bar files have been created. So you see, so they are concatenated. So now I am having a single matrix where all the clusters are getting concatenated, and along with that we have the ARO modules. Okay. So in a single CSV file, I have all the details. I have the information for all the 4 clusters of the Acinetobacter. I have information for the k-bar of the E. coli, and along with that, I have all their class name information like the ARO number and the unclassified. So that single file now I'll be calling over here. So this is the actual SVM model that I have implemented. So this is the splitting the data into the training and testing part. Like I told you, I have to keep the majority amount of portion for the training purpose, and the less amount of portion, say 20 to 30% for the testing purpose. So here I am doing the same thing, just splitting the data into training and testing. And if I run this particular file, and over here I am computing all the measurement metrics like accuracy, precision, recall, and F1 score. These 4 measurement metrics I have computed, and this is the result I have to read from. So accuracy 0.9575, like that means accuracy I am getting 95.75%. Precision I am getting 96.5%, recall 95.75%, and Take-home score is 95.66%. So that is the model score for this particular data. So the model itself has taken the training and the testing part. It will do the averaging on the output matrix and it will give you other results. So as I am getting a very good amount of these values, like more than 90% is really good enough. So that's why I can say the model is performing really well. So now you can, now the model has been trained and tested. So for this model, you just create an unknown sequence, you just give it as the input to the model, it will give you that which particular antibiotic is resistant to. Now that is the first target that has been achieved so far. The next target is we have to identify the patterns for which the classification is being so good. Okay. So for that, this is the score that I am computing. So when I am running this particular file, it will take a time because all the KMR values that I have taken. So 4 to the power 4 is how much? 256. So 256 value it will compare. It will try to find out that which significant KMR patterns are important to do this classification. You can utilize k equals to 6, then at that point of time, how many KMR values you will have? 4 to the power 6. You can use k to the power k equals to 8, then at that point of time you will have say 4 to the power 8. Like that way number of computations you will have. So the file is right now running, so at approximately it will take few minutes to complete. And at the output we will see it will give us all the patterns like the KMR patterns for which, and along with that it will give us the score for each pattern. So yeah, right now it is completed, the file. So yeah, you see this is the output. So GGTG is giving me the highest pattern of 57.3%. PGA is giving me the second highest pattern. Like this way, I have all the patterns which have been stored over here. Okay. So more than 40% or 30% you can take and you can utilize your form. Okay. So that is all for this particular Acinetobacter file. Now, same thing which we can do for all other pathogens. So these are the different results that we have got. Since we have just shown you using the K mark, 4 mark. But here I have computed all the values for 6 mark, using 6 mark and 8 mark as well. For all the pathogens. For 5. For like 5 different pathogens, I have utilized this kind of thing, and this is the matrix that we have got. Okay. So, in summary, like let me tell you that whatever the basic learning model, like the support vector basic we have utilized over here, it can very much accurately classify the data into different clusters. Cluster means each cluster is resistant to a particular antibiotic or group of antibiotics. And the algorithm can also provide us the important patterns, the nucleotide patterns for which we can easily identify that with any kind of unknown sequence, whether it will be resistant to which category of antibiotics. Okay. And that's all about my today's talk. Yeah, this is the team. This is my team. The first, this is the first floor. These are the students who is presently working with me, developing machine learning algorithms for sequence data as well as for image data. And these are our group of faculty members with whom I am presently working for having a diversified knowledge in bioinformatics, genomics, and all these things. So I'm working with them because I told you I'm very much bad in biology. That's why I have to take care of a lot of help. So yeah, that's all. And the last thing that I have written somewhere on the internet that whether you believe it or not, but this is the practice that we believe. AI will not replace you, definitely, from your career point of view, but a person having a knowledge of AI will. Thank you.